Welcome to the Deep Dive. Today, we're plunging into something that really feels like it redefines what AI can create. We're talking Google DeepMind's Genie 3. If you thought AI video generation was getting impressive, well, prepare for a pretty significant shift, because this isn't just about watching AI content. We're talking about creating and actually stepping into interactive navigable worlds.
That's exactly it, yeah. Genie 3 is an astounding leap in what DeepMind actually calls generative interactive environments. Its whole mission is basically to create these dynamic, playable worlds just from text prompts. It moves us light years beyond, passive media. So in this deep dive, our mission is to peel back the layers on its architecture, explore its, well, frankly, mind-bending capabilities, and crucially, understand its strategic importance for the future of AI. We'll be drawing insights from DeepMind's own announcements, early technical analyses, basically trying to show you how it pulls off these feats and what it really means for you, for the whole AI landscape.
Okay, let's definitely unpack this. Before we dive headfirst into Genie 3, where did this Genie journey actually start? What was the groundwork, the foundational magic, if you will?
Right, so the journey kicked off with Genie 1. DeepMind unveiled that back in February 2024. And that was the foundational proof of concept for this whole generative interactive environments idea. Its core innovation was, well, it was genuinely remarkable. Imagine an AI just watching millions of YouTube videos.
Sure.
Just watching them, right? And figuring out completely on its own how to move a character or jump or interact with things without anyone telling it what those actions even were.
So no labels, no instructions on this means jump.
Exactly. That's what Genie 1 achieved. It learned frame-by-frame controllability in a totally unsupervised way, just by observing unlabeled internet videos. You could give it a single prompt, maybe synthetic image, a photo, even like a rough hand-drawn sketch. And Genie 1 could generate a playable 2D platformer-style world from it. This wasn't just clever programming. It was a fundamental shift. It let AI understand interaction purely from observation. That's huge for developing generalist AI agents.
That's a fascinating breakthrough, especially the unsupervised part. But maybe for someone like me, more of a general tech enthusiast than, say, an ML researcher, how did it actually do that without the explicit instructions? What's the core tech?
That's a great question, and it really gets to the cleverness behind it. Genie 1 was an 11 billion parameter model, huge, trained on an absolutely massive amount of video, like 30,000 hours, mostly 2D platformer games.
30,000 hours, wow.
Yeah, and it had three key pieces. First, a spatiotemporal video tokenizer. Think of it like distilling raw video down into its essential compact building blocks, like taking a huge video and boiling it down to a small set of Lego bricks that capture the key info, essential for handling all that data.
Compressing it down.
Right. Second, the latent action model, or LAM. This was the real kicker, the innovation. It inferred a discrete latent action. Basically, it figured out the most important change between one frame and the next without human labels. It learned its own vocabulary of just 8 basic, semantically consistent actions, things like move right or jump, but it discovered them itself.
Self-taught actions, okay.
And finally, the auto-regressive dynamics model. That was the engine generating the world. It took the previous frame and your chosen latent action to predict the next frame, using some pretty smart techniques for efficient pixel generation.
So Genie 1 lays that groundwork, learning control from video. Amazing. But the leap to Genie 3, creating these rich 3D interactive environments and in real time. That feels like going from, I don't know, a sandbox to an entire planet. How did DeepMind even start to bridge that kind of complexity gap?
You've absolutely hit on the core challenge, yeah. And the scale of the leap. Genie 3, announced August 2025, moves way beyond Genie 1's 2D limits. It generates these rich 3D interactive environments from text prompts. And crucially, it does it not as some pre-rendered clip, but in real time. We're talking 720p resolution, smooth 24 frames per second.
Real-time 3D generation from text.
Exactly. And the key architectural shift, based on what DeepMind shared, is this novel auto-regressive pipeline that rereads the entire action trajectory every frame. Now, what that means is Genie 3 isn't just looking at the very last frame to predict the next one. That's called a Markovian process in the field, kind of short-term memory. Instead, it's history conditioned. It looks at the entire sequence of your actions, almost like it's replaying your whole journey up to that point, every single frame.
Every frame. That sounds computationally intense.
Well, incredibly intense. But that's what underpins its acclaimed long horizon consistency and this almost magical sounding emergent visual memory. It's what lets it maintain coherence in the world for several minutes, which is a long time in this context.
That emergent visual memory. It does sound like magic, as you said. So
Yeah.
how does it actually achieve that consistency?
Yeah.
And the dynamic control, how does it stop things just drifting into nonsense?
Yeah, it's a serious engineering feat. One of the biggest hurdles with these autoregressive video models is drift. Small errors build up over time, the world loses coherence, things start looking weird.
Right, I've seen that in some earlier video AI demos.
Exactly. Genie 3 massively reduces this problem because of that history condition pipeline we mentioned.
Yep.
By constantly reevaluating the entire action trajectory for each new frame, its understanding of the current state isn't just based on the last second, it's rooted in the initial prompt and everything you've done since. That's how it stays consistent for several minutes and remembers static things for at least 1 minute. And you're right, to pick up on it doesn't build an explicit 3D model of the scene like, say, a game engine does with meshes and textures. The consistency just sort of arises from the process.
So it learns consistency rather than being programmed with it.
Precisely. It's computational demanding, absolutely, but hitting real-time 24 FPS suggests some seriously optimized implementation under the hood.
That makes more sense.
Yeah.
Okay, what about controlling it? Beyond just moving around, can you actually influence the world once you're inside it?
Dynamically. Yes, exactly. The level of control is a huge standout feature. It works on 2 levels. First, there's the initial world generation. You give it a high-level text prompt, like a mountainous environment in the Alps, and boom, it creates the whole interactive starting point.
Okay, the initial setup.
But then, and this is really cool, once you're in the simulation, you can use promptable world events. This means you can literally type things like, make it rain, or maybe build a cave entrance over there, and the environment dynamically adapts to your new instruction without reloading the whole thing.
Whoa, okay, so you can just type commands mid-play.
That's the idea.
Yeah.
This dual-level control implies a pretty sophisticated multimodal architecture, right? It's likely integrating powerful text encoders, maybe components from models like Gemini, and injecting those text commands directly into the generative model's latent space to sort of nudge the world in the direction you want.
And here's where it gets truly mind-bending for me. The source material talks about implicit physics without a physics engine. What on earth does that mean? Are we talking about things just floating weirdly, or does it kind of vibe with gravity? If it's not using a traditional physics engine, could I prompt a world where water flows up a mountain? Would Genie 3 just go with it, or would it break?
That's a fantastic thought experiment, and it really gets to the heart of what's so fascinating here. Genie 3 does simulate complex water behavior, gravity, shadows, even the specific sound and feel of, say, tires crunching on volcanic rock. But it does all this without a hard-coded, rule-based physics engine like you'd find in Unreal Engine or Unity. Its understanding of physics is totally implicit. It's learned statistically from that massive data set it trained on. It's what some call intuitive physics. The model isn't solving fluid dynamics equations. Instead, it's learned the probabilistic patterns of pixels that usually correspond to these phenomena. When it generates a ball in midair, it knows statistically it should probably move downwards next, because that's what it saw millions of times in training videos.
So it's pattern matching on a massive scale.
Exactly.
Yeah.
So your water flowing uphill example, Genie 3 aims for plausible versions of reality, not perfect simulations. It leans on those statistical patterns. It would likely try to render your gravity-defying water in a way that looks statistically plausible, even if physically impossible. It might look surreal, maybe a bit weird, but it wouldn't necessarily crash or break like a traditional game engine hitting an impossible instruction, which is a wild thought.
It really is.
The advantage is this incredible flexibility. It can blend physics with artistic style. Remember the origami-style lizard example? Try doing that easily in a standard physics engine. The trade-off, though, is precision. It's not mathematically exact. So you might see occasional glitches or inaccuracies, characters walking backwards briefly, maybe snow that doesn't quite settle realistically. It's plausible, not pixel-perfect physics.
Plausible, not perfect. That's a really powerful distinction. Okay, so given that DeepMind hasn't dropped a super detailed technical paper on Genie 3 itself yet, how can we peek behind the curtain? How do we get clues about how it achieves this real-time performance? It's clearly not magic, right? There must be some clever engineering.
You're spot on. It's brilliant engineering, definitely not magic. And while they're keeping the full Genie 3 architecture under wraps for now, a related project, Genie Envisioner, gives us some massive clues. Genie Envisioner, or GE, was developed around the same time. It's described as a unified world foundation platform for robotic manipulation. Sounds complex, but it likely shares core engineering ideas with Genie 3.
Okay, so insights from robotics.
Exactly. The key insight here seems to be something called slow, fast, asynchronous inference. Imagine you have two parts of the system. One part does the really heavy lifting, the complex visual understanding of the world. That part runs relatively slowly. Then you have another part, much lighter, that generates the quick, precise actions, or in Genie 3's case, maybe synthesizes the final frames. That part runs super fast.
Like a slow brain for deep thinking and a fast brain for reflexes.
That's a great analogy, yeah. Genie Envisioner uses this. A heavier world model, GE base, processes the environment maybe at 5 hertz, 5 times a second. But a lighter action model, GE Act, generates robot control signals at 30 hertz, 30 times a second. This decouples their speeds. The expensive visual stuff happens less often, and its outputs get cached or reused by the faster action part.
Ah, so the fast part isn't waiting for the slow part every single cycle.
Precisely. And the slow-fast design is almost certainly a key part of how Genie 3 hits 24 FPS while still doing that history reevaluation we talked about. It likely uses a slower deep state world model to update the core environment understanding based on the accumulated history. And then a much faster rendering or frame synthesis decoder spits out the final view at the full 24 frames per second. That approach, plus likely training on very specialized integrated data sets like GE-used robotics data, is what enables these really capable world models.
Okay, that architecture makes the real-time aspect seem much more achievable. So Genie 3 isn't operating in isolation then. How does it really stack up against the other big names in generative AI? You hear about OpenAI Sora, maybe NVIDIA Cosmos. It gets confusing figuring out who's doing what.
That's a critical point, yeah, and it boils down to a core difference: interactivity. Models like Sora or Google's own VO3 or Runway's Gen 3 Alpha, they are fundamentally non-interactive generators. Think text to movie. They're optimized for cinematic quality. High-resolution VO3 aims for 4K and making sure the output really matches the prompt visually. But it's a finished clip. You watch it, you don't play it.
Right, they make movies.
Exactly. Genie 3, though, it's built as an agent-playable world. Its success isn't just about looking pretty, though it looks impressive. It's measured by the stability, the responsiveness of the interactive experience. Even if the resolution is currently 720p, not 4K, the point is you or an AI agent can actually play inside it. That's the fundamental difference.
So different goals entirely.
Totally different goals. And even when you look at other things called world models, Genie 3 has its own specific niche. NVIDIA Cosmos, for instance, is really focused on super high-fidelity, physics-accurate simulations. Think industrial digital twins, creating synthetic data for training robots in very specific realistic scenarios. Meta's VGPUT-2 is different again. It prioritizes learning world understanding from just watching vast amounts of passive internet video, aiming for things like action anticipation or zero-shot planning. Less about generation, more about understanding. Then you have startups like Descartes with their Oasis platform, targeting maybe gaming or user-generated content, focusing more on cost efficiency and accessibility for creators.
Okay, so different angles.
Right. And Genie 3 sits uniquely as this general-purpose, promptable, real-time world model explicitly designed for AI agent training. It's balancing realism, interactivity, and that crucial prompt control, all tailored for its big strategic goal: creating this unlimited curriculum to push towards artificial general intelligence, AGI. That's its core purpose and competitive edge.
Okay, that positioning makes a lot of sense. But while Genie 3 sounds revolutionary, you mentioned limitations earlier. Every cutting-edge tech has trade-offs, right? What are the main ones here?
Absolutely, no technology is perfect, especially early on. DeepMind has been pretty open about Genie's current constraints. The big one is probably the interaction horizon. Worlds are stable and consistent for a few minutes, which is great for experiments, but not hours or indefinitely. Environments aren't persistent, yet you can't save your world, leave, and come back later to find it exactly as you left it.
Ah, so no saving your game yet.
Not in that sense, no. Then there's the physics and fidelity. We talked about the intuitive physics. It's impressive, but imperfect. You get occasional visual glitches, unnatural movements sometimes, maybe snow that doesn't quite settle right. It generates a plausible version of a place, like the Alps, but not a perfect, photorealistic digital twin.
Plausible, not perfect. Got it.
The action space is another limitation currently. It's mostly about navigation, moving around. Complex object manipulation, picking things up, using tools. That's still pretty narrow. Multi-agent dynamics are also tricky. Getting multiple independent AI agents to interact realistically and believably within the world is a hard problem it still struggles with. And finally, a common issue with many generative models: rendering clear text. Unless you specifically prompt it to show text, it often has trouble generating legible words within the scene.
Okay, so given those limitations, it's not quite a game engine. Worlds aren't infinitely persistent. What's its real purpose then? Why are these trade-offs acceptable, maybe even strategically necessary, like you hinted?
They are absolutely acceptable, even necessary, once you grasp DeepMind's core strategic goal for Genie, providing that unlimited curriculum for AGI research. Think about training generalist AI agents using reinforcement learning. One of the biggest bottlenecks is data. Getting enough diverse, high-quality, real-world data is incredibly expensive, time-consuming, and often unsafe or just impossible. Handcrafting simulations helps, but they lack diversity and scale.
Data bottleneck, right.
Genie 3 aims to solve that. It offers a potentially near-infinite supply of training environments generated on demand and, crucially, controllable via prompts. That long-horizon consistency, even if just for a few minutes, is vital for training agents on tasks that require planning and memory over multiple steps.
Longer than just reacting instantly.
Exactly. And those promptable world events are a game changer for researchers. They can instantly generate rare, dangerous, or just very specific scenarios like navigating a busy street during a sudden hurricane or practicing avoiding lava flows on an alien planet, things you just can't easily stage in the real world or find enough video of.
Creating edge cases on demand.
Precisely. So for AGI research, the ability to generate, say, 1,000,000 different 5-minute volcanic environments to rigorously test a robot's navigation policy, that's vastly more valuable than having a single, visually perfect 10-hour simulation of just one volcano. This is why diversity, controllability, and scalability are prioritized right now over absolute photorealistic perfection or endless persistence. It's fundamentally a scientific instrument.
A tool for research, not necessarily a consumer product yet.
Exactly. Its initial release as a limited research preview for academics and creators really underscores that positioning. It's a tool to accelerate AI discovery. And if we connect that to the bigger picture, what's next for Genie? Where does the project likely go from here? Well, the current limitations pretty clearly map out the research roadmap you'd imagine. A major goal has to be extending the horizon, right? Pushing that interaction duration from minutes towards hours, maybe eventually aiming for truly persistent, savable worlds. Then richer interaction and embodiment, expanding what agents can do in these worlds beyond just navigation, more complex object manipulation, using tools likely integrating learnings from related projects like Genie Envisioner on the robotics side.
Making the agents more capable within the world.
Yes, multi-agent social physics is another huge challenging frontier. How do you get multiple AIs interacting believably, maybe even learning socially from each other within these generated environments? That's complex. And finally, a perennial challenge: improving sim-to-real transfer. Bridging that gap so that the skills an AI agent learns inside a Genie world actually transfer effectively and safely to a physical robot operating in the real world. That remains a critical open problem for the whole field and something the Genie platform is clearly designed to help tackle.
This has really been a fascinating deep dive. It's crystal clear that Google DeepMind's Genie 3 isn't just, another incremental update. It feels like a significant paradigm shift in how we even think about AI-generated content. We're moving beyond just passively watching AI creations to actually actively creating and interacting with these on-demand realities. And like you said, it's not just about games or entertainment, though the potential there is obvious. It's fundamentally positioned as this strategic research instrument to push the boundaries of artificial general intelligence. It's really quite compelling how the whole Genie portfolio seems to fit together, from Genie 1 laying the foundation to Envisioner tackling robotics, all feeding into this vision for Genie 3.
Indeed, it really is about blurring that line between just observing a world and being able to actually conjure one, control it, learn within it. So maybe as we wrap up this deep dive, here's something for you, the listener, to think about. What stands out to you most about the potential implications of creating these on-demand, interactive realities, and how might that fundamentally change how we learn, how we play, or even how we design and build things in the future?